Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 1 in a session October-November 2021 Paper 1-2. So let's start with the first question. Question number 1, solve the equation. So let me shift all the terms to the left side. 2 cos theta minus 7 plus 3 over cos theta equals to 0. Then let's multiply through both sides of the equation by cos theta, right? Multiplying by cos theta, 2 cos square theta minus 7 cos theta plus 3 equals to 0, right? Let's factorize this. 2 times 3 is 6, and we have 6 times 1 is 6, minus 1 minus 6 is minus 7. 2 cos square theta minus cos theta minus 6 cos theta plus 3 equals to 0. 2 cos theta is common. We are left with cos theta minus 1. Negatives 3 is common. Sorry, not 2 is common. We just cos theta is common. Okay, 2 cos theta and minus 1, right, equals to 0. We are left with cos theta minus 3 is the factor, and 2 cos theta minus 1 equals to 0. So these are the two factors. Now let me put both factors separately equals to 0 to get the value of theta. So from here, cos theta minus 3 equals to 0, cos theta is equals to 3, and theta is cos inverse of 3, which is undefined. Let me check from calculator as well, because cos values is between minus 1 to plus 1. It is in degrees, right? Because the domain is in degrees. Let me convert my calculator into degrees first. Cos inverse of 3, which is undefined, right? Okay, now let me find the value from the other root. 2 cos theta minus 1 equals to 0. From here, cos theta is 1 by 2, and theta is cos inverse of 1 by 2, right? Okay, so what is cos inverse 1 divides 2 is 60 degree. So theta is 60 degree, and we know that cos is positive in first and fourth quadrant, but we have given the range of theta lies between minus 90 to plus 90 degree, minus pi to plus pi. The other value of theta is negative of 60 degree. Negative 60 is also cos 60 is 1 by 2, cos minus 60 is 1 by 2, because cos is the even function, it absorbs the negative sign. So these are the two solutions between minus 90 to plus 90 degree. Question number 2, the graph of y equals to f of x is transformed to the graph of y equals to f of 2x minus 3. Part A, describe fully the two single transformations that have been combined to give the resulting transformation. Right, so first we have y equals to f of x as a base function. Then we have y equals to f of 2x, right? So what is 2 over here? So 2, this 2 value is basically the stretch by a factor of 1 by 2 in x direction. Stretch by a factor of 1 by 2 in x direction. Right, and we have y equals to f of x minus 3. This negative 3 is a vertical translation, 3 units to the left. Vertical translation, 3 units left. So these are the two set of combined transformations that are applying on the function f of x, right? Now for the second part, the point P, which is 5, 6, lies on the transformed curve y equals to f of 2x minus 3. Part B, state the coordinates of the corresponding point on the original curve. So this point P lies on the transformed curve. We have to find the coordinates of the original curve, right? Okay, so as we know that this point P lies on y equals to f of 2x minus 3. So to find the original point, what we have to do, so we have a point 5 and 6, right? So the origin, this is a transformed one. Okay, so when we have a vertical, we have a stretch in x direction by a factor of 1 by 2. So in x direction, it's 1 by 2. So we need to multiply the x coordinate by 2. We do the reverse now, right? In order to multiplying by 1 by 2, we have to multiply by 2, and in order to subtract 3, we add 3 in y values, right? Okay, so we can say that xy changes to 2x and y plus 3, right? So this is 5, 6. This changes to 2 times of 5, 6 plus 3, right? 2 times of 5 is 10 and 6 plus 3 is 9. So the point 5, 6 changes to 10 and 9. So these are the coordinates of the corresponding point on the original curve. Question number 3, the function f is defined as follow. We have f of x where x is greater than 1. Part A, find the value of f of 5, right? So first let me solve for f of 5. 5 plus 3 over 5 minus 1. 5 plus 3 is 8, 5 minus 1 is 4, and which is 2, right? So from here we have f of 5, which is f of 2. So what is f of 2? F of 2 is 2 plus 3 over 2 minus 1. So 2 plus 3 is 5 over 1, which is equals to 5, right? Now for part B, find an expression for f inverse of x. So first thing, we need to put y equals to f of x, which is x plus 3 over x minus 1. Then we have to switch the variables. X would be equals to y plus 3 over y minus 1. And then we have to solve for y. Let's do the cross multiplication. Xy minus x would be equals to y plus 3. Shifting all the terms to the left side, or y terms to the left side and the other terms to the right. Okay, taking y common, we have x minus 1 equals to x plus 3. Okay, and then we have y, which is equals to x plus 3 over x minus 1. So this y is my f inverse of x, right? Question number 4, a curve is such that dy by dx is given. The curve passes through the point 2 and 5, 2 by 3. Find the equation of the curve. Okay, so we have 5 times 3 is 15 plus 2 is 17 over 3, which is 5.67. 2 and 17 over 3. This is a point. We need to find the equation of curve. We have given dy over dx, which is equals to 8 into 3x plus 2 power minus 2, right? We need to integrate on both sides with respect to dx. So we are left with y, which is 8 is outside. We need to do the power rule. 3x plus 2 minus 2 plus 1 over minus 2 plus 1, multiply 1 over the derivative is 3 plus some constant of integration, right? So y would be equals to 8 over 3 with a negative sign into 3x plus 2 plus some constant of integration. Now to get the value of c, let's use the point, which is 2 and 17 over 3. Okay, the y value 17 over 3, 8 over 3 into 3 times 2 plus 2 plus c, right? So we have 17 over 3 minus 8 over 3 times 2 is 6, 6 plus 2 is 8, 8 times 3 is 24, This is the C value. Okay, 17 over 3 subtract 8 over 24, which is 16 over 3. 16 out of 3 is your C value, the constant of integration. Sorry, we have a minus sign here, which is plus 17 over 3 plus 8 over 24, which is 6, right? So the C value is 6. The equation of curve is y equals to negative 8 over 3 into 3x plus 2 plus 6, right? This is equation of curve. Question number 5. The first, third, and fifth term of an arithmetic progression are 2 cos x minus 6 square root of 3 cos x plus 10 cos x and 10 cos x respectively for x is between pi by 2 to pi. Part A, find the exact value of x. Okay, so we have given the first term of arithmetic progression is a, which is 2 cos x. The third term, which is a plus 2d, which is equals to minus 6 square root of 3 sine x. The fifth term is a plus 4d, which is equals to 10 cos x. Right. Okay. Now let me substitute the value of a in the second and the third equation. This is my equation 2 and this is equation 3. Right. So let's say this is 1. We can say put equation 1 in equation 2 and equation 3, right? So we have 2 cos x plus 2d, this is equals to negative 6 square root of 3 sine x. Let me solve for d from here, right? So we can say 2d is minus 6 square root of 3 sine x minus 2 cos x dividing by 2d would be equals to negative 3 square root of 3 sine x and negative cos x. This is equation static, right? The second one is, we can say 2 cos x plus 4d is 10 cos x. So 4d is equals to 10 cos x minus 2 cos x. 10 minus 2 is 8 cos x, right? So 4d is 8 cos x. 4 times 2 is 8, so d would be 2 cos x. This is equation double star, right? So we have the d value. We can compare equation static and double static to get the value for x, right? So we can say comparing equation star and equation double star, right? So we can say negative 3 square root of 3 sine x minus cos x, this is equals to 2 cos x. Negative 3 square root of 3 sine x is equals to 2 cos x plus cos x. So we have 3 cos x minus 3 square root of 3 sine x equals to 3 cos x, right? Okay, 3 is cancelled with 3. Negative square root of 3 sine x equals to cos x, right? Now let me divide by cos. So minus square root of 3 sine x over cos x, this is equals to 1, and sine over cos is tangent x, which is minus 1 over square root of 3, right? Now let me solve for x. X is tangent inverse of 1 over square root of 3. We have to solve for the positive one first, right? Okay, so the domain is in radians. Convert the calculator in radians and find tangent inverse of 1 divided square root of 3, which is pi by 6. X is pi by 6. Now here this equation says the tangent is negative. So the tangent is negative in second and fourth quadrant, right? So for second quadrant, and the fourth quadrant the tangent is negative. Let's find the value of x. For second quadrant we have to do 180 minus theta, so pi minus pi by 6. Pi minus answer is 5 pi by 6. And for fourth quadrant we do 2 pi minus pi by 6. 2 pi minus pi by 6, which is 11 pi by 6. Okay, the domain we have given that the range of the x values are between pi by 2 and pi, right? So the only solution is this, right? That belongs to the given range, right? Only solution is 5 pi over 6, that belongs to pi by 1 by 2 pi to pi, because 5 by 6 is between 0.5 and 1, and 11 by 6 is more than 0.5 and 1. Yeah, right. Now for the part B, hence find the exact sum of first 25 terms of the progression. We have to find as 25, which is 25 over 2 into 2a plus 25 minus 1 into d, right? So what is a? A is the first term, which is 2 cos x. So 2 cos, the x value we got is 5 pi by 6. Let me solve this. Cos 5 pi, pi by 6 and times by 2 is negative square root of 3. This is the a value, and the d value is 2 cos x, which is again negative square root of 3. Okay, let's substitute over here and to find the sum of 25 terms, right? So as 25 is 25 over 2 into negative 2 square root of 3 negative 24 into square root of 3, right? Square root of 3 negative 2 negative 24 is 25 by 2 and negative 26 square root of 3. Okay, 25 times 26 divided by 2, which is 325. So negative 325 square root of 3 is the exact sum of first 25 terms of this progression. Question number 6. The second term of a geometric progression is 54 and the sum to infinity of the progression is 243. The common ratio is greater than, r is greater than 1 by 2. Find the 10th term giving your answer in exact form. Okay, so we have given the second term, which is a r, which is 54, and s infinity, which is a over 1 minus r, is 243, right? So from this, let me solve for a from here. A is 54 over r. Substitute here, which is 54 over r into 1 minus r. This is 243, right? So we have 54 over r minus r square is 243, right? And let me do the cross multiplication. 54 equals to 243r minus 243r square, right? Shifting all the terms to the left side, this will give me 243r square minus 243r minus 54. This would be equals to 0. This is plus 54 already on this side, right? Okay, now we need to factorize this. The common factor of 243 and 54 is 27. 243 divides 27 is 9 r square minus 9r, and 54 divides 27 is 2. plus 2 equals to 0. Okay, factors are 9 times 2 is 18, and we have to make okay, 3 times 6 is 18, and negative 3 negative 6 is negative 9. 9r square minus 3r minus 6r plus 2 equals to 0. Okay, let me take 3r common. 3r minus 1 is left. Negative 2 is common. 3r minus 1 equals to 0. So the two factors are 3r minus 1 and 3r minus 2 equals to 0. So from here we put both factors equals to 0. R is 1 over 3 or R is 2 by 3. Okay, so 1 by 3 is 0 0.3 and 2 by 3 is 0 0.6. So we have given the information that the common ratio is greater than 1 by 2, greater than 0 0.5. So this is 0 0.3, it is lower. So this is greater than 1 by 2. This is the common ratio R, right? Okay, now we have we need to find the 10th term. For 10th term we need the first term and the common ratio. We have the common ratio. Now A2 we have given, which is A into R. R is 2 by 3. It is 54. Let me solve for A from here. So A would be equals to 54 times 3 by 2. Okay, 54 times 3 divided by 2 is 81. 81 is the A value. Now let's find the 10th term. So for 10th term of geometric progression, we have A10 is A R power 9. So A is 81, R is 2 by 3, its power is 9. Okay, so 2 by 3, its power is 9, and times by 81, this is 515. 512 over 243. 512 over 243. This is the 10th term of the progression in the exact form. Question number 7. In the diagram, the length of AB, A to B and A to C are both 15 centimeter. Okay, it means the triangle ABC is an isosceles triangle. Two sides are same, two angles are same. Okay, point P is, this is a point P, is the foot of the perpendicular from C to AB, right? The length of CP, C to P, is 9 centimeter. An arc of a circle with center B, this is a center of a circle, B, passes through C and meet AB at Q. So this is the arc BCQ. Part A, show that the angle ABC, this angle we have to show, which is 1.25 radians, correct to 3 significant figures. Okay, so consider the right angle triangle APC, right? Consider triangle A, P and C. This is a right angle triangle, right? We have AC, which is 15. We have CP, which is 9, right? Okay, so we need to find this. Let's solve for angle A, right? So what is angle A? So to get this angle, we have the opposite side and the hypotenuse. So we use sine. Sine of A is opposite is 9, hypotenuse is 15, right? 9 out of 15, so which is in terms of radians. So 9 over 15 and sine inverse of answer, this angle is 0.6435, right? So from here we have angle A, which is 0.634 up to 3 significant figures, right? Okay, so we have this angle A, and we know that the triangle ABC is an isosceles triangle. Two sides are same, two angles are same. Angle B and angle C should be same, right? So if we use a concept of sum of all angles of a triangle is 180, sum of all angles of triangle, right? So we can say angle A plus angle B plus angle C is 180 degree, or in radians we have pi, right? Okay, so we have angle A 0.634 Angle B is, let's say, x. Angle C is also x, which is pi, right? Okay, so we can say 2x is pi minus 0.634, and x would be equals to pi minus 0.634 divided by 2. Okay, so we can say pi minus answer divided by 2. This is 1.249 up to 3 significant figures, 1.245. Yes, 1.25. You need to round up to 3 significant figures. So the angle x, we can say this angle B is 1.25 radians. Now for part B, calculate the area of the shaded region. So this is a shaded region which is bounded by the arc CQ, C to Q, and the line CP and PQ. Okay. So basically we have to find the area of this sector, subtract the area of this triangle. So area of a sector is half radius square theta. We have the radius, we don't have the radius. O, Q, BC is the radius, BQ is the radius, and we have theta. So first we need to find BC and then PQ as well for the area of a triangle. Yes. Let me consider this right angle triangle A, C and P. So we have AC 15, CP is 9. What is P and AP, right? So if I can say this is hypotenuse, applying the Pythagoras theorem, yes. Finding the length AP. Consider the right angle triangle A, P and C. Okay, the hypotenuse is 15 equals to the one leg of the triangle, another one is AP square. So we can say AP square is equals to 15 square minus 9 square, right? So 15 square minus 9 square is 144. So AP is equals to 12, right? So since AP is 12, let me show you guys. Okay, A to P, this length is 12, this whole length is 15, so this length is 3. 3 plus 12 makes 15, right? So this length is 9, this is 3. Again, considering the right angle triangle BPC, right? And applying the Pythagoras theorem, consider the right angle triangle B, P and C. The hypotenuse is BC that we have to find. The two legs are 9 square plus 3 square, right? Simplify 9 square is 81 plus 3 square is 9 and square root of 90 is 3 square root of 3. So BC is 3 square root of 10, sorry. 3 square root of 10 is BC, right? Okay, so we have the length BC, which is 3 square root of 10. This is 9.5. We can take 9.5 centimeter. Okay, now the thing is we need to find this is a radius. Yes, 9.5 is the radius. Okay, now let me find the area of the shaded region. The first thing we need to find area of a sector. Area of sector of a circle with a center B, which is half radius square theta. Okay, so we have half, the radius is 3 square root of 10, its whole square, and theta is angle B, which is 1.25. Okay, now it's square times 1.25 and divided by 2. This is equals to 56.25, 56.25 centimeter square. And now find the area. This is the area of a sector BCQ, this sector. This one is not shaded, so subtract the area of this triangle, right? So we can say area of a triangle is half base times height, because it is a right angle triangle. Base is 3 and the height is 9. 3 times 9 divided by 2, which is 13.5 centimeter square. Right, now let's find the shaded area. Shaded area from the sector area, which is 56.25, we need to subtract the triangle 13.5, which is not shaded. Right, 56.25 minus 13.5, this is 42.75 or 42.8. 42.8 centimeters square is a shaded area which is bounded by the arc and the two lines. Question number 8, part A. It is given that in the expansion of 4 plus 2x into 2 minus ax power 5, the coefficient of x square is negative 15. Find the possible values of a. So we have 4 plus 2x and the product of 2 minus ax power 5. So this is 4 plus 2x into, we have, if I can say 2 power is 5 plus 5c1, 2 power is 4 and negative ax power 1. Okay, plus 5c2, 2 power is 3 and minus ax square, and so on we can take. Okay, so from here we have 4 plus 2x and its product with 32. Okay, this is negative 5c1 times 2 power 4 is 80 ax. It's positive 5c2 times 2 cube is 80 a square x square, up to so on. Okay, now let's do the product, and we need to find only the coefficient of x square, right? So when 4 is multiplying with this term, it's constant x and x square, right? 4 times 80 a square x square. 2x, this is x term, this is x square term. 2x times minus 80 ax plus up to so on. Okay, so simplify. 4 times 8 is 16. 32, sorry, 4 times 8 is 32. Yes, 320 a square x square ax. Yes, 2 times 8 is 16 minus 160 ax square. Right, now we have given the coefficient of x square is negative of 15. So let me solve, put it equals to negative of 15. So 320 a square minus 160 of a is negative of 15. 320 a square minus 160 of a and plus 15, this would be equals to 0. We have to find the possible values of a. So it's a quadratic equation in a. So first let me simplify. 320 divided by 5 is 64a square. 160 divided by 5 is 32a, and positive 15 by 5 is 3, equals to 0. Right, now let me factorize this. We have 64 times 3 is 192 and 24 times 8 is 192, and negative 24 negative 8 makes negative 32. 64a square minus 24 of a minus 8a plus 3 equals to 0. Right, so let me take 8a common. 8 times 8 is 64 and 8 times 3 is 24. Minus 1 is common. 8a minus 3 equals to 0. Right, so the two factors are 8a negative minus 1 and 8a minus 3 equals to 0. Right, put both factors separately equals to 0 to solve for a. So a is 1 over 8 or the a value is 3 over 8. We need to find the possible values of a. So these are the two values for a, 1 by 8 or 3 by 8. Now for part B, it is given instead that in the expansion of the product, the coefficient of x square is k. Before we have the coefficient of x square is negative 15. So what was the equation? We have the equation which is 320a square minus 160 of a. This is equals to k. X square coefficient is k. It is also given that there is only one value of a which leads to this value of k. Find the value of k and a. Okay, if there is only one value of a which leads to this value of k, one value of a which leads to this value of k, it means the discriminant should be equals to 0 for one solution. So 320a square minus 160 of a minus k equals to 0. For one solution, we can say b square minus 4ac equals to 0. So b square is minus 160 whole square minus 4 times the a value is 320 and the c value is minus of k. This should be equals to 0. Okay, so we can say 160 square is 25600, right? And we can say 4 times 320 is positive 1280k, and this should be equals to 0. We are solving for k. 1280k, this is minus 25600, right? So we can say 25600 divides 1280. This is equals to the k value, which is negative of 20 by dividing. So when k value is negative 20, so what is the a value? So okay, put k equals to negative 20 here. So we have 320 a square minus 160 a plus 20. This should be equals to 0. Over here we put negative of 20, right? Now let me solve for a. So if I can divide by 2 by 20, right? 320 divided by 20 and 160 divided by 20. Yes, it's possible. 320 over 20 is 16a square. 160 over 20 is 8. Negative of 8a plus 1 equals to 0. So the factors are 16 times. Okay, if I can take, this is 4a whole square minus 2a, and the b value is 1 plus 1 square. This is a minus b whole square. 4a minus 1 whole square equals to 0. Or we can take, say that 4a minus 1 equals to 0. 4a equals to 1. So a equals to 1 by 4. So we can say the only value of a is 1 by 4 when k is negative of 20. Question number 9. The volume V meter cube of a large circular mold of iron ore of radius R meters is modeled by the equation V for R is greater than equals to 2. Iron ore is added to the mold at the constant rate of 1.5 meter cube per second. So 1.5 is basically dV over dt we have given. Part A, find the rate at which the radius of the mold is increasing. At the instant when the radius is 5.5 meters. Okay, so we need to find dr over dt at r is equals to 5.5. This thing we have to find. Okay, so we have given the volume. So if I can differentiate dv with respect to r, the volume with respect to the radius, we have 3 by 2 is as it is. Applying the power rule, so we have 3 into r minus 1 by 2. 3 minus 1 is 2, and the derivative of r is just 1, and the derivative of negative 1 is 0, right? So this would be equals to 9 over 2 into r minus 1 by 2 whole square, right? Now let me apply the chain rule. We need to find dr over dt. Okay, and we have given dv over dt. So dr over dt, this would be equals to dr over dv into dv over dt. right? So we have dv over dr, right? So let me find what is dv over dr at r is equals to 5.5 meters. 9 by 2 into 5.5 minus 1 by 2 whole square. Let me simplify. 5.5 minus 0.5, it's square, times by 9 divided by 2, which is equals to 112.5. Okay, now let me substitute into the chain rule. We have dr over dt. This would be equals to dr over dv, the reciprocal of this, which is 1 over 11 1112.5 times dv over dt is given 1.5, right? So let me simplify. 1.5 divides answer, which is 1 over 75 or 0.01333, or just write down 1 over 75 or 0.0133. Now for part B, find the volume of the mold at the instant when the radius is increasing at 0.1 meter per second, means dr over dt is given, which is 0.1. So we have given dr over dt, which is 0.1, and dv over dt, which is 1.5, right? This dv over dt we have given, right? We need to find the volume. Okay, so what is dv over dr? This is dv over dt times dt over dr, and this would be dv over dt is 1.5 times dr over dt reciprocal 1 over 0.1. Let me simplify. 1.5 divided 0.1, this is equals to 15. So we have dv over dr value from the first part, which is 9 by 2 into r minus 1 by 2 whole square. This is equals to 15. R minus 1 by 2 whole square equals to 15 times 2 over 9, the reciprocal. 15 times 2 divided by 9, which is 10 by 3. Right, now we have to solve for r. We can do square root on both sides. We have r minus 1 by 2 equals to square root of 10 by 3, right? And what is r? R is square root of 10 by 3 plus 1 by 2. 10 by 3 square root of 10 by, okay, 10 divides 3 plus 1 by 2, which is 2.33. 2.33 is the radius. Now let me find the volume of the mold. So the volume has an equation which is 3 by 2 into r minus 1 by 2 cube minus 1. So when r is 2.33, we can say v is 3 by 2 into 2.33 minus 1 by 2 cube minus 1. So let me simplify. Subtract 1 by 2 and take its cube times by 3 divided by 2 and then subtract 1. 8.13. So V is 8.13. This is a volume of the mold, right? Question number 10. The function f is defined by f of x equals to this for x is greater than 0. Part A. Given that the curve with equation y equals to f of x has a stationary point. For stationary point, we have to find do f prime of x equals to 0. When x equals to 2, find k, right? So we have a stationary point. So for stationary point, we have to do f prime of x, which is 2x minus k over x square plus 0, right? And it has a stationary point at x is equals to 2. So at x is equals to 2, for stationary point, we have to put the first derivative f prime of x equals to 0. So we can say 2x minus k over x square is equals to 0. At x is equals to 2, we can easily find the k value. 2 times 2 minus k over 2 square equals to 0, right? So 2 times 2 is 4 minus k over 4, this would be 0. 4 equals to k by 4, and 4 times 4, the cross multiplication, 16 is the k value, right? Now for part B, determine the nature of the stationary point. For the nature of the stationary point, we have to find the second derivative of the curve. So we have to differentiate d by dx of 2x minus k over x square, right? Its derivative is 2, and the derivative is we have plus 2k over x cube, right? Now for nature, we have to do f double prime at x is equals to 2. So 2 plus 2 k value 16 over 2 cube, right? Let me simplify. 2 times 16 divided by 8 is 4 plus 2, which is equals to 6. So this is 6, it is greater than 0, so the nature is minimum, right? Now for part C, given that this is the only stationary point of the curve, find the range of f. So we have given that x equals to 2 is the only stationary point. So what is the function value at 2? So we have 2 square plus 16 over 2 plus 2. So we have 16 divides 2 plus 2 plus 4, which is equals to 14, right? So we have given the domain that x is greater than 0, right? So the stationary point is basically the turning point of the curve, right? We need to find the range. So the output we will get is 14. So the range is greater than 14. This implies the range of f of x is greater than equals to 14. Values are, because the domain is greater than 0, more than 0, so the range, the output we will get is more than 14. Question number 11. The diagram shows the line x equals to 5 by 2, the part of the curve y equals to this, the part of this curve, and the normal to the curve at a point A. So this is the equation of normal to the curve at point A. Part A, find the x coordinate of the point where the normal to the curve meets the x-axis. So when it meets the x-axis means the y coordinate is 0. So first we need to find the equation of normal to this curve. So for equation of normal, we have to differentiate. We need to find y prime at point A, which is 3, right? So let me find the derivative. It is 1 by 2. This derivative is 0, and we have minus, and we need to do the power rule over here. The derivative is minus 1 by 3 if I shift it to the numerator, and x minus 2, its power is minus 1 by 3 minus 1, and the derivative is just 1. Minus 1 by 3 and minus 1 is minus 4 by 3. Okay, so 1 by 2 plus 1 by 3 into x minus 2 minus 4 by 3, right? This is a derivative. Now let me find the derivative at point A, right? So y prime at x is equals to 3 is 1 by 2 plus 1 by 3 into 3 minus 2, power is 4 by 3. Okay, 3 minus 2 is 1, and 1 power 4 by 3 is 4 by 3. So we have just 1 by 2 plus 1 by 3, which is 5 by 6. Okay, now what is the gradient of normal? Gradient of normal is negative reciprocal of gradient of tangent, which is negative 6 by 5, right? So the equation of normal is y minus y naught equals to m into x minus x naught. right? So let me substitute. We have y minus y naught is a 0.6 by 5, m values minus 6 by 5 into x minus 3, right? We need to find the x coordinate when y equals to 0. At y equals to 0, we can solve for x, right? Okay, when y is 0, we have minus 6 by 5 equals to minus 6 by 5 into x minus 3. Let me solve for the x coordinate. So if I multiply both sides by minus 5 by 6, we will get 1 equals to x minus 3. So 1 plus 3 equals to 4 equals to x. So we can say that the x coordinate of equation of normal is equals to 4 and the y coordinate is 0, right? So here this x coordinate is equals to 4, right? Now for part B, find the area of the shaded region, giving your answer correct to 2 decimal place. So this is a shaded region. We need to find its area. Okay, let me find out the area. So if I draw the straight line, area under this curve basically, if I draw this straight line here, the x coordinate is 3, right? We need to find area of this portion and this triangle, right? So area of a triangle is half base times height. Base is 3 to 4 is 1, and the height is, we have an height of 6 by 5, right? Okay, and we need to find area under the curve, integration of this curve between 5 by 2 to 3, right? And we can add both of them. So basically the shaded area is integration of the y between 5 by 2 to 3, right, with respect to dy dx, plus area of a triangle, which is half base times height. As you guys can see, the base is, the distance between 3 to 4 is 1 unit, and the distance from 0 to 6 by 5 is just 6 by 5. So the base is 1 and the height is 6 by 5, right? So this implies, first let me integrate from 5 to 2, 5 by 2 to 3. The function y is 1 by 2x my plus 7 over 10 minus x minus 2, power is minus 1 by 3 dx. Okay, so we have 1 by 2 is outside, we have x squared over 2 plus 7 by 10 is outside, it's x, minus, applying the power rule, we have x minus 2 minus 1 by 3 plus 1 minus 1 by 3 plus 1, and the limits are between 5 by 2 to 3. Okay, so x square over 4 plus 7x over 10. Okay, we have minus 1 over 3 plus 1 is 2 by 3. So negative 3 by 2, x minus 2, its power is 2 by 3, and the upper and the lower limits are 5 by 2 to 3. Okay, let me substitute the upper limit first. We have 3 square is 9 over 4 plus 3 times 7 is 21 over 10 minus 3 minus 2 is just 1, and 1 power anything is 1, so minus 3 by 2. This is my upper limit. Subtract the lower limit is 5 by 2, so 5 by 2 square divided by 4 is 25 over 16 plus 7 by 10 times 5 by 2. 5 by 2 times 7 divides 10 is 7 by 4, right? And the last is 5 by 2 minus 2. 5 by 2 with a negative sign, subtract 2, and its power is 2 by 3. Okay, times by 3 divided by 2 is 0.945. Okay, let me simplify now. Times minus 1. Okay, let me do this. 9 divides 4 plus 21 over 10 minus 3 by 2 is 57 over 20 minus 25 over 16 plus 7 by 4 minus 0.945 minus 2.3675. 57 over 20, subtract answer. Okay, 57 divides 20, subtract answer. This is 0.4825. Right. Now let me find the shaded area, which is a sum of 0.4825 and half base times height, half times 1 times 6 by 5. 1 by 2 times 6 by 5, 3 by 5, 0.6. 0.4825 plus 0.6, 1.08. 1.08 square units is the shaded area. Sorry. Question number 12. The diagram shows the circle with the equation x square plus y square minus 6x plus 4y minus 27 equals to 0 and tangent to the circle at the point P, which is 5, 4. So the point P is 5, 4. Okay, so the equation of circle and the tangent to the circle at point P, right? Part A, the tangent to the circle at P meets x-axis at point A and y-axis at point B, right? So it has the coordinate x0 and it has the coordinate 0, y. Find the area of the triangle AOB where O is the origin. O is the origin, AOB, right? So we need to find what is this x and what is this y coordinate to find the area of the triangle AOB by using the formula half base times height, right? Okay, so first let me find the center of a circle. So the circle is x square minus 6x plus y square plus 4y minus 27 equals to 0, right? So we have x square minus 2 times x times 3 plus 3 square, right, plus y square plus 2 times y times 2 plus 2 square minus 27 minus 3 square is 9 and minus 2 square is 4 equals to 0. Adding and subtracting. This is x minus 3 whole square plus y plus 2 whole square, and we have negative 27, negative 9, negative 4, which is negative 40, or we can say equals to 40. So the center of a circle is 3 minus 2, right? X is 3 and the y is minus 2, right? Let's say this is a center of a circle C, right? Okay, now we need to find the equation of tangent to the circle at point P. So as we know that tangent is always perpendicular to the radius or diameter of a circle, right? So we need to find the gradient of radius, which is PC, point P to C. So P point is 5, 4 and the point C is 3 minus 2, right? Let me find out the gradient. y2 minus y1 minus 2 minus 4 over 3 minus 5. This is negative 6 over negative 2, which is 3. This is gradient of radius. So what is the gradient of tangent? Tangent is always perpendicular to the radius or diameter of a circle. So this is perpendicular. Gradient of tangent is minus 1 over 3. Right, now let me find the equation of tangent, which is y minus y naught is 4 equals to minus 1 over 3 into x minus x naught is 5. Now let me find the coordinates for point A and B, right? So the coordinates of A are x 0. We need to solve for x when y is equals to 0. Minus 4 is equals to negative 1 over 3 into x minus 5. Okay, 4 times negative is cancelled with negative. 4 times 3 is 12 equals to x minus 5. 12 plus 5 is the x value, which is equals to 17, right? So we can say that a is 17, 0, right? Let me solve for b. The b coordinates are 0, y. We need to solve for y when x is equals to 0. Y minus 4 equals to minus 1 over 3 into minus 5, right? So what is y? Y equals to 5 over 3 plus 4. Okay, 5 by 3 plus 4, which is 5.67, or 17 over 3 in terms of decimal. So the coordinates of b are 0 and 17 over 3. All right, now we have to find the area of a triangle AOB. Let's do this. Area of triangle AOB, which is half base times height. Base is the distance OA, as you can see, O to A, which is the x is 17, and the height is O to B, the y 17 over 3, right? Into 17 into 17 over 3, right? So let me solve for the area. We have 17 times 17 is 289. 2 times 3 is 6. 289 over 6, or we can say 48.2 square units is the area of the triangle AOB. Now for part B, points Q and R also lies on the circle such that PQR is an equilateral triangle. Okay, Q and R, these 2 points also lies on the circle, and the triangle PQR is an equilateral triangle having 3 sides and 3 angles are same. Okay, let me draw this triangle. All the 3 sides are same and all the 3 angles are 60 degree, right? Okay, the question is find the exact area of the triangle PQR. So we need to find the exact area of this triangle PQR. Okay, if I connect the P, we know that from center to the point on the circumference is the radius. CP is the radius, CR is the radius, CQ is the radius. Okay, and this hole is 60, so this angle is 30 degree. This angle is 30 degree, and the remaining angle is 120 degree. Same 30, 30, 120, 30, 30, and 120. So these are the 3 identical triangles. We have to find the area of the 3 triangles. Area of 1 and times by 3, we will get the exact area of the triangle PQR, right? So we already found that the radius, this is a radius. This is R square. Radius square is 40. Okay, and radius is square root of 40, right? So let me find the area of triangle CPR, which is half the 2 sides, which is square root of 40 into square root of 40 and sine of 120. Let me simplify in degrees. Sine 120 times by 40 divided by 2, which is 10 square root of 3. This is 10 square root of 3, right? So we can say that area of triangle PQR is the sum of 3 triangles. So 3 times of 10 square root of 3. So this would be equals to 30 square root of 3 square units. This is the exact area of the triangle PQR. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.